Hello, friends. Let's do some comparisons of the parabola, the ellipse, and the hyperbola. So if we talk about the parabola and we look at what its equations look like in standard form, we have x squared is equal to 4py, or y squared is equal to 4px when the parabola's center is at 0, 0. And remember that p represents that distance between the center to the focus and to the directrix. Remember that when the x is being squared, that means you have a parabola opening up or down. And when the y squared is, or the y is being squared, that you have a parabola that's opening up side to side. When you have it centered not at 0, 0, it would look like x minus h squared equals 4py, or y minus k. Or it would look like y minus k squared equals 4p times x minus h. Again, where when the x is being squared, that's an up or down parabola. When the y is being squared, it's a side-to-side parabola. And p is always that distance that is between the directrix to the vertex and from the the focus to the center and the center to the directrix. All right, so now let's talk about the ellipse versus the hyperbola. I personally think if you're going to make a mistake, this is where it's going to be at, because they look a lot alike, they just have some subtle changes. For instance, the ellipse is going to look like x squared over a squared plus y squared over b squared equals 1, versus the hyperbola is x squared over a squared minus y squared over b squared equals 1. Both of these do have a center at 0, 0. But because of the plus, it's an ellipse. Because of the minus, it's an hyperbola. And that should make sense, because in an ellipse, when you take any point on the ellipse to its foci, the sum is constant, versus in a hyperbola, whenever you take a point on the hyperbola to each of its foci, its difference is constant. Next, the major axis is always the bigger number. So when you are talking about the equation of an ellipse, you could have x squared over a squared, over b squared plus y squared over a squared equals 1. So in this case, the x is the major axis, and in this case, the y would be the major axis, because the major axis is always the bigger number. So this means the ellipse would be wider than it is tall. This means it would be taller than it is wide. But with the hyperbola, it's always about the variable that comes first. So since the x is first, we would have a horizontal transverse axis. So my hyperbola is opening up left to right. If I had y squared over a squared minus x squared over b squared equals 1, then again, it doesn't make a difference if a or b is bigger, the y is first. So this means I have a vertical transverse axis, so my hyperbola is opening up or down. I'm not going to go through the cases where you don't have it at 0, 0. I think we've had enough practice that you realize that we would just have x minus h, the quantity squareds, and y minus k is the quantity squareds. But the last thing I want to point out is that when you're trying to find information about the foci, in an ellipse, you subtract the denominators, the a squared minus b squared, but in a hyperbola, you add them. Also remember, hyperbolas have asymptotes. Ellipses do not. And our last conversation with this lesson is that you can classify a conic from its general equation. So notice how I have ax squared plus cy squared plus dx plus ey plus f equals 0. If a equals c, and a does not equal 0, this means that you would have a circle. If you would take a times c and it equals 0, this means that a equals 0 or c equals 0. And if a would equal 0 or c it was equal to 0, but not both, this means that you would only have one of the variables squared. So if only one of the variables is squared, this implies that you would have a parabola. If you take a times c and it's greater than 0, in other words, a and c would have like signs in order to be greater than 0, either they are both positive or both negative, then you would have an ellipse. And that makes sense because in an ellipse, the coefficients on your x squared and your y squared, you're adding them. They would be the same. And if you multiply the a times the c and it's less than 0, so a and c have unlike signs. I'm so sorry for just a minute. Can somebody please let in the dog? He keeps barking and I'm trying to record. Pardon me. Welcome to Life at the Knop House. If a times c is less than 0, that means a and c would have to have unlike signs. Then this is a hyperbola. All right, so what would an example look like from your homework? If I gave you x squared plus 4y squared minus 6x plus 16y plus 21 equals 0, and you have to classify this as which conic section it would be, you really only have to focus on, hi Harper, that's the clickety-clacking of my dog on the floor. All you need are the squared terms. The coefficient on the x squared is 1. The coefficient on the y squared is 4. Well, they're not equal to each other, so it's not a circle. When I take a times c, I do not get 0, so it's not a parabola. 1 and 4 are like signs, so when I multiply them together, it's greater than 0. Therefore, the equation of this is an ellipse. This can be very helpful to you on a test because you could definitely look at the general form and know what should happen before you even start completing the square. However, if you were in a bind and you don't remember these rules, like if all of this was like, oh my gosh, I can't remember, when you start completing the square, so x squared minus 6x plus 4y squared plus 16y equals negative 21. And then when I would complete the square, x squared plus 6x plus 9 plus 4, this would be y squared plus 4y, complete the square is 4, but I'm really adding 16. I would yield x minus 3, the quantity squared, plus 4 times y plus 2, the quantity squared, equals 4. So I would yield x minus 3 squared over 4 plus y plus 2, the quantity squared over 1 equals 1. And now I notice that I have a sum where I have an x squared and a y squared. So this is another way, obviously, after you've done the work that you can determine it's an ellipse. So at this time, you can finish the assignments by looking at page 656 and 47 to 55, the odds, and 57. Good luck.